Welcome back, dear students. Today we are going to discuss about data mining, the third chapter in your module 3. So till now we have discussed two chapters in this module, that is business intelligence and its applications and data warehousing. In today's video class, we are going to discuss about data mining. What is data mining and what are the techniques used in data mining that we are going to discuss. So what is data mining? As it is mentioned in the first point, data mining is art and science of discovering knowledge, insights and patterns in the data. So there are three keywords here. So what are those? Discovering knowledge. It is collection of data. So using this collection, what we are doing, we are discovering knowledge, we are having insights on the collected data, and we are carrying some patterns here. We are discovering for some patterns in data that is useful for our business, right? So it is an art of extracting useful patterns from an organized collection of data. So patterns must be valid. Okay, they should be valid one and novel one. Novel means not yet discovered. Okay, and they should be potentially useful and also understandable. So this implicit assumption is that data about the past can reveal patterns of activity that can be projected into future. So these patterns, they will help us to predict our future. That is why we are going for data mining. Okay, then data mining, as you all know, it is a multidisciplinary field that borrows techniques from all the other fields. Okay, so it utilizes knowledge of data quality and data organizing from the databases area. Then it draws modeling and analytical techniques from statistics and computer science. So we come across statistics and computer science, that is artificial intelligence areas in data mining, right? So it also draws the knowledge of decision making from the field of business management. So that is what we have to see here, what it borrows from different types of fields. So the field of data mining emerged in the context of pattern recognition, right? So it came from pattern recognition. So such as identifying whether a person is friend or an enemy in a battlefield, like many other defense inspired technologies, right? So I can give you an example here of data mining. So customers who buy cheese and milk can also buy bread 90% of the time. So this is an assumption. So these kind of patterns or insights can be done using data mining, right? So you can analyze pattern, and this would be useful pattern for a grocery store which we can prepare, so which can then stock the products appropriately. It is used by the grocery mart owner to stock the products properly, right? Similarly, people with blood pressure greater than 160 and age greater than 65 are at high risk of dying from heart stroke. This is one of the example. Okay, and it is a great measure for diagnosing for our doctors, so who can then focus on treating such patients with urgent care and great sensitivity. Okay, so past data can be a predictive value in many complex situations here, especially where the pattern may not be easily visible without the modeling technique. Okay, so I have given you two examples, and you have a case study. You can go through it. Data mining in retail shops, how it is helpful, right? Then how it is carried out by other two companies like Facebook and Google. This is case study, so I'm skipping it. Then what are the essential requirements for data mining that we are studying? So the first requirement is we have to gather and select the data. So the first step in data mining is gathering and selecting the data. So here what we do is the total amount of data in the world is doubling every 18 months. See this statistics. Total amount of data, world's data, is doubling every 18 months. Means if you have some 100 TB of data in the world, now in 18 months it will be 200 TB. So can you imagine what is the size of data that the world is having? It is in petabytes, not in petabytes, exabytes maybe, right? So as we can see here, there is a ever growing avalanche of data coming with higher velocity, volume and variety. See here, there are three characteristics of data. First one is velocity, volume and variety. Velocity refers to the fast incoming data that we have to store, and volume means it will come in a large volume, and variety means it has many forms. Data may be unstructured, data may be structured. Structured means the data stored in databases. Unstructured means the data that comes from IoT devices, for example, right? So one has to quickly use it, or he is in a great chance of losing it, right? So smart data mining requires choosing where to play, right? What kind of data has to be uh, invoked, or what kind of data has to be used for one's uh, good purpose. Then one has to make judicious decisions about what to gather and what to ignore, right? Based on the purpose of the data mining exercises, he has to know, when he is running a business, he should know what is useful and what is not useful. So it is like deciding where to fish. Not all the streams of data will be equally rich in potential insights. So this is an example. So in online shopping, the owners like Flipkart and Amazon, they will be looking for proper data of a user, right? They'll not go for medicinal history. They are not interested with the customers medical histories, right? They are only interested with how they shop in online market. Okay, so no, they should decide where to fish. Not all the streams of data will be important for everyone. Okay, then every organization will be having their own EDM, that is the enterprise data model. So using this enterprise data model, you can create databases, or you can store the data how much you want, and you can use it for your own purpose for the later insights, right? And you can see here many types of data will be there. Unstructured data, so it comes from many streams like machine generated data or RFID tags and all. So these kinds of data you will get. So this is first step, gathering and selecting data, right? You need to know from where you have to gather the data, and from the gathered data which data you need actually. So if as I've previously mentioned, if a user's data is measured, shopping data, like he buys toys, he buys perfumes, he buys some medicines. Now Amazon and Flipkart are only related with the other things, toys and his dressing sense or like that. It is not concerned with the medical history of the patient or what he buys, medicines what he buys. Okay, that is what I told about selecting the data, right? Gathering and selecting the data, that is the first step in data mining. Okay, then the second step in data mining is data cleansing and preparation. So the quality of the data is critical to the success and value of the data mining project, right? And the situation will be of the kind of garbage in garbage out. If it is not the clean and proper data, then the quality of incoming data varies by the source and nature of the data, right? And data from internal operations is likely to be of higher quality as it is accurate and consistent. But data from social media and other public sources is not under our control, right? So we need to do some uh, operations on this data that we gathered and selected. So that is called as data cleansing and preparation. So what do you need here? You should remove the duplicate data. Okay, the same data may be received from multiple sources. When merging the data sets, data must be deduped or duplicates must be removed, right? That is first point. Then the second point, you need to fill some missing values, or there may be some rows that should be removed from analysis, right? Missing values can be filled with the average or model or default values. Okay, so if you are if you are given your user a registration form, and if he has not filled some mandatory options, then you can make your own links to fill them. So that is called as data cleansing. Okay, then the third point is that is called as missing value filling, right, in data cleansing. Then data elements may not be transformed from one unit to other unit, right. Then the fourth point is continuous values may need to be binned into few buckets to help with some analysis. For example, we can say work experience could be binned as low, medium and high. That is, you need to categorize, right. Then the fifth point is data elements may need to be adjusted to make them comparable over time, like currency values may need to be adjusted for inflation. Okay, then that is an example. Then outlier data means the data which is not behaving properly, right, that is called as outlier data, that should be removed. Then any biases in the selection of data should be corrected, right, that is the seventh point. Then the eighth point, data should be brought to the same granularity. In order to compare two types of data, then they should be brought into same granularity. Okay, then the last point is data may need to be selected to increase information density. Sometime here some data may not show such variability because it was not properly recorded for any other reasons. So this data may dull the effects of other differences in the data, and it should be removed, okay, to improve the information density of the data. So these are the 9 points you need to remember in case of data cleansing and preparation. Okay, then the next point is outputs of data mining. What are the outputs of data mining? So the outputs of data mining will reflect the objective being served. So data mining techniques can serve different types of objectives, right? So these outputs of data mining will reflect the objective being served. There are many representations of output of data mining, and one popular form of data mining output is a decision tree. So what is decision tree? Decision tree, it is a hierarchically branched structure that helps visually follow the steps to make a model based decision. So you can have regression equation, you can have centroid, you can have some business rules. We will discuss it one by one. So the first one, there are evaluating data mining results. In evaluating data mining results, we have two kinds. First one is supervised learning and unsupervised learning. So what do you mean by supervised learning? It is a decision model which can be created using past data, and the model can then be used to predict the correct answer for future data instances, right. So classification is the main category of supervised learning activity. A common metric here is predictive accuracy, which can be given as predictive accuracy is equal to correct predictions divided by total predictions. Okay, so this is confusion matrix. I think you already know it. So here we have predicted class and true class. Predicted class versus true class, it is negative positive and positive negative, and we have some definitions like what is true positive. When a true positive data point is positive, that is a correct prediction, which is called as true positive, TP. Then similarly, what is a true negative? When a true negative data point is classified as negative, that is a true negative, right. On the other hand, when a true positive data point is classified by the model as negative, that is incorrect prediction, that is called as false negative, right. False negative means when a true positive data is classified by a model as negative, then it is called as false negative. It is in the name itself, right. Then similarly, what is false positive? When a true negative data point is classified as positive, then it is called as false positive, right. So this model is called as confusion matrix. Then predictive accuracy according to confusion matrix is what? It is TP plus TN divided by the sum of all these things. TP plus TN, which is equal to correct predictions, right, divided by all sum of all these numbers, that is TP, FP, FN and TN. Okay, so this is one measure. Whatever things I have explained is in this slide. This is one measure to calculate predictive accuracy. Okay, then data mining techniques, we have learned this. So under supervised learning learning techniques, those are called as classification. We have decision trees, we have ANN, we have regression, and under unsupervised learning we have cluster analysis, we have association rule mining. Okay, so what are decision trees? So these are popular mining techniques. As I already told you, it is hierarchical structure. It is hierarchical tree which are easy to understand and easy to use by analysts. So they select the most relevant variables automatically out of all available variables. These things you have learned in machine learning. So decision trees are tolerant of data quality issues, and they have even non-linear relationships can be handled by decision tree uh, in a good way, right? There are many algorithms to implement decision trees. For example, C5, CART, and CHAID are some of the algorithms that can be implemented using decision trees. Okay, coming to regression. What is regression? Regression is a simple and most popular statistical data mining technique. Right? What is the goal of it? Goal of it is to fit a smooth, well-defined curve to a data. Right? Given data. Then regression analysis techniques, for example, can be used to model and predict the energy consumption as a function of daily temperature. So this is one of the example. Simply plotting the data shows a nonlinear curve. Applying a non-linear regression equation will fit data very well with a high accuracy. So that is one of the use of regression. Then thus the energy consumption on the on any future day can be predicted using this equation. So what is done here? Electricity bill prediction is done in this example of regression. Then coming to the next point, that is artificial neural networks. So ANN is a sophisticated technique, as you already know, in data mining. So what you have here is you have a technique wherein human brain or human neural structure is imitated, right? Neurons receive stimuli and they will process them and communicate the results to other neurons successively. Thus a large neural network is created, and how it works you all know, right? So this is the same type of neural structure is imitated by a computer program that is called as artificial neural network. Okay, then coming to cluster analysis. Here it is a exploratory learning technique. The first one was classification. Here it is exploratory learning technique, which helps in identifying a set of similar group in the data, right? You have learned k-means technique, right? What is k-means technique? The k-means technique is a popular technique, and it allows user guidance in selecting the right number of clusters from the data. That cluster is given by the value k. Okay, this is all about cluster analysis. Then coming to association rules. So what are association rules? So these are the methods in business, especially where selling is involved. So this is the I'll give an example. If you are buying some goods in Amazon and streaming movies like Netflix, so there are some affinities, so you can create some relationships, like the one I have mentioned in the previous example. Like if you are buying bread and cheese, you are likely to buy milk, like that. So these are called as association rules. Okay, then coming to tools and platforms for data mining. So there are a wide range of data mining platforms available in the market today. So there are simple end user data mining tools such as MS Excel, and you have more sophisticated tools such as IBM SPSS Modeler. Then there are standalone tools. There are open source and freely available tools like Weka. There are text-based and GUI-based tools, and there are tools that work on proprietary data format, that is mentioned data format. Okay. Then this is comparison of popular data mining platforms. I'll leave it. This is not so important. Then coming to data mining best practices. This is one of the important question. Write down the question. Explain crisp DM data mining cycle. This will be asked for 6 to 8 marks. Okay. So this is crisp DM data mining cycle. We have data in the middle. We have some cycle of processes here. What are those? We have deployment, we have evaluation, we have modeling, we have data preparation, we have data understanding, we have business understanding. So the first step is as usual, business understanding. The second step is data understanding. Third step is data preparation. Fourth step is data modeling, evaluation, deployment. So this is how the crisp DM data mining cycle is there. So in the first step, that is in business understanding, it is an important step in data mining, that it is asking the right business question. So business understanding means asking the right business questions. The question is question is a good one if answering it would lead a large payoffs for organization. Then financially, it will help that company. Then in other words, selecting a data mining project is like any other project in which it should show strong payoffs if the project is successful. So there should be strong executive support to understand the business, right? Then the second important step is to be creative and open in proposing imaginative hypothesis for a solution. That is data understanding. So if you want to understand data, you should be creative and you should be open in proposing imaginative hypothesis for a solution. Then thinking outside the box is important in this step, right? Then coming to the third point, that is data preparation. Data should be clean and high quality. So in the data mining process, the second step is data cleansing process. So here this comes into picture, that is in data preparation. So data should be clean and of high quality. It is important to assemble a team that has a mix of technical and business skills, right? So data cleaning can take 60 to 70% of the total time of this cycle, right? Then the next step is modeling. So patience is required in continuously engaging with the data until data yields some good insights. So you should model what you are doing actually with your data that you have, right? Then the next one is evaluation. So what is evaluation? One should not accept what the data says at first, right? So you have to evaluate the model's predictive accuracy with more test data here in this step. And the last step is deployment or dissemination or rollout of the system into the real environment. So this is your data mining cycle. This is crisp data mining cycle. Okay, so this is very important. What is crisp? Crisp is cross industry standard process for data mining, right? Crisp DM, that is cross industry standard for DM means data mining. So this question will be asked. You have six steps, so it will be asked for 6 to 8 marks. So if it is asked for 8 marks, 2 marks will be for a diagram and 6 marks for your 6 points of explanation. Or if it is asked for 6 marks, then you need to draw the diagram and you need to explain 6 points, right? So this is all about data mining best practices. Okay, then coming to myths about data mining. So these are some of the myths. This is not an important question, but it's there in your syllabus, so we are discussing. So myth 1 is data mining is about algorithms. No, it is not about algorithms, but it is the way in which we mine the data, in which we predict the future of an organization using data. Then data mining is about predictive accuracy. It is not only about predictive accuracy, it has other things too. Then data mining requires a data warehouse. No, it requires a data warehouse, but it is not at all of it. Then data mining requires large quantities of data. Yeah, but you can do it with small entities of data also, right? Then data mining requires a technology expert. No, anyone can do. Okay, then coming to data mining mistakes, there are some of the mistakes. Mistake 1, that is selecting the wrong problem for data mining. So without right goals or having no goals, selecting the wrong data for the data mining leads to some mistakes. Then buried under mountains of data without clear metadata. So you have huge number of data, you don't know what you are doing, you don't have a clear idea about your metadata. So that is one of the mistake. Then disorganized data mining. So without any clear goals, if you organize your data, then it is just a waste of time. Then your next mistake is insufficient business knowledge. If you don't have a deep understanding of your business, then you don't know what to mine or what kind of data you need to mine. That is one of the mistake. Then mistake 5, incompatibility of data mining tools. So all the tools for data gathering, preparation, mining and visualization should work together, right? They should go hand in hand, right? Then mistake 6, locked up in data jailhouse. So using tools that can work with data from multiple sources in multiple industry standard format may look like you have locked up in the data jailhouse. So that is one more mistake. Then mistake number 7, looking only at aggregated results, right? That is also a mistake. Then mistake number 8, running out of time. So not leaving sufficient time for data acquisition. If you go for data mining, so it is just waste, and it is although running out of the time also. Then coming to ninth mistake, measuring your results differently from the way your sponsor measures them. So this comes from losing a sense of business objectives. So when you lose your business objectives and begin to mine the data for its own sake, then you will get into this mistake. And the last one, mistake number 10, naively believing everything you are told about the data. So don't naively believe everything you are told about your own data mining analysis. So these are some of the data mining mistakes that you will do, right? So in this chapter, what we have learned, I'll just quickly glance. So you have learned what is data mining, and what are the steps in data mining. So the steps are gathering and selecting the data, then cleansing the data, and preparation. Then these are the outputs of data mining. So you have learned confusion matrix, and you have learned some data mining techniques, supervised learning and unsupervised learning. In these two varieties, we have learned 5 different techniques. So you have to be in a position to write notes on all these things. Okay. Then we have learned what is crisp DM data mining cycle, right, with 6 points of explanation. Then we have learned myths about data mining and mistakes we do when we go for data mining. So this is all about this chapter. In the next video, we are going to learn about data visualization, the last chapter in module 3. Okay, so till then, take care, have a nice day. Thank you.